All right. So this week we're back with Ruby, who's a delight in pink every single time. And we're going to talk about 3D modeling, which is something that we have both done a fair amount of. And we're going to talk about all the fun ways that you can do it. And we're going to talk about it at several different levels of accessibility, several different tiers of if you want to just get started with it for the very first time, if you want to go nuts and really become an expert. It's been a minute, but I reflected at some point recently, and I've been 3D modeling for 20 years. So I've got a lot of experience doing this.
Pro status.
Well, it's for a long time. So it's something that you got to keep in mind. It's a skill that you build over time. It's not one that you just whip up into existence. But here's the game plan. Ruby and I looked at these and tried to make sure that they were coming in the right directions. We're going to talk, and at any time, and this is true for, as we've said before, at any time, please feel free to interrupt, ask a question, talk about a thing. If you've got experience, please share it. There's a lot of great ways to make cool stuff happen, and we want to hear about it if you've got an idea that spins off of ours. So first up, we're going to talk about all the different crazy 3D modeling options there are, then really double down on 2 of them. Tinkercad, which is fantastic for beginners, and can go for a long time. You can have a lot of fun with Tinkercad for many, many years. And Fusion 360, which is in the same, where it's a little odd, but we're sticking to the same company because it's like a pipeline that makes sense. So Fusion 360 is sort of their for grown-ups version. It's not SolidWorks. SolidWorks is, and we'll talk about it all, but these are 2 in the Autodesk pipeline that could be approachable things. Then we'll go over the basics of drawing in 3 dimensions because it's weird, advanced, common 3D modeling concepts, and some other strange things. But we're going to talk about all sorts of 3D modeling. Here's a whole bunch of pictures. Ruby, how many of these have you done?
Maybe 3.
That sounds great. I think I've probably turned on more, but have I felt proficient with probably 4 or 5 of these? I think if you were to track back my 20 years, it started with Blender, which is for artists and making movies and stuff. And I was just mostly playing around. Now I'm a big Fusion 360 fan. Tinkercad is one we're going to recommend, and it's great. And it works for everybody down to I've taught it to 4th graders without a problem, all the way up to adults who use it because you want to make something real fast, and it works really nicely. SolidWorks, if you're a paid engineer, you're probably using this one, is likely the case. Onshape, you can do on a Chromebook. There's other crazy ones. This Antimony was made by one guy, and it's Linux only and very cranky about it. But it's a lot of fun. Unreal Engine and Unity, you might know about from games. OpenSCAD is if you want to write your 3D shapes with code. If that's your jam, you can totally write code and make them happen. That's the extent of the talking about it we're going to do, although I can show you that if you want. But there's a lot of cool things. As we start to think of how do you even process all of those options, and those are just some of the options for 3D design software. Does anybody in the room have any experience with any others of these? Yeah? What do you got, Lourdes?
I'm actually recently learning Fusion 360 right now.
Yeah.
It's mostly, I know Blender, but only to an extent.
Sure.
I know how to make 3D shapes, but then apply 2D animations over it. Does that make sense?
Yeah. No, that sounds fun.
Otherwise, yeah. So that's it.
Cool. And ZBrush, which did that even make the list? Oh yeah, and Ibrahim uses Creo, which is another one. I've seen his Creo. I've never downloaded or turned that on, but it looks, I saw him working on it Tuesday, and it really I feel like I could turn it on and feel natural. It had a lot of the same buttons and clicks and logos for things. Yeah.
I used Maya.
Oh, cool.
My college courses.
Oh, because I was Maya is so expensive.
Yeah, it was
Yeah.
awesome through my college, but
Yeah,
it's not intuitive, but it's so much that you can do with it.
Yeah, I have an old childhood friend. There's photos of us in diapers, but that does a lot of Maya. He loves it.
So is DreamWorks 3D software.
Oh, cool.
Was released yesterday, I believe.
Oh,
But it's only available on Linux. So that
I'm into that.
software is responsible for, I believe, Puss in Boots, the new one that came out.
Whoa.
So just it's also an open source, so it's actually very fun to have Linux.
Yeah. It's like when a software, and I'm not decrying Linux in any way, but when a software is Linux only, it's like the same as having a campsite with no power, no water, tents only, right? Like there's just only some people are going to go there.
Really target.
Yeah, Onshape is great. On your phone, Onshape is real gutsy. I like it's totally possible, but man, that like terrifies me to think about it. But you can do it on a tablet. Like it's really great. There's a few of these that are Chromebook accessible, which is an important thing to think about if you're a teacher, because all of your students have Chromebooks and they've probably taken out all the actual computers from your school. So that's an interesting thing to think about when you're making your choices.
And my kids use Tinkercad on their Chromebooks.
Yep.
Great tutorials.
Yeah.
I do nothing. I still can't make chess piece, but I only need to have.
Yeah, that's fine.
Thank you.
All right. So when I think about all of these and all the different ones that I've tried and thought about, I think about them in three different camps, like three different categories, and they definitely blur the borders in lots of the different software suites. There's some that are volumetric, and for anybody who's played with Tinkercad already, it is a volumetric, volumes first 3D design. Everything is 3D when you start in Tinkercad, and it always is 3D, and there's never a 2D version that you get out of it, except to like export at the end. So you'll see in a second, we're going to look at Tinkercad first. Everything is 3D as a first principle. Sketch and extrude is what SolidWorks and Fusion 360 and Onshape and lots of the professional tier ones use, because they all stem from the historical mode of an engineer with a drafting table. So it starts with a flat sketch, and then you extrude it into 3 dimensions. It was a natural extension when they designed AutoCAD to do designs of like buildings and car engines and stuff that an engineer needed to draw by hand. It felt like a natural transition for an engineer. Then there's this crazy 3D mesh designer. This is like Maya. The one softwares like that, or Mesh Mixer. Autodesk has a Mesh Mixer also, where you can directly edit the triangles of an STL. And Blender does that also, mostly. Those sorts of 3D mesh designers are really cool, and they're almost always artist focused, because it's hard to get like the same machinist like precision you'd get as if you did engineering style designs. Many of the softwares will let you blur those lines, but these are sort of the 3 big camps I think about them in. So here's our recommendation. We talked about it, and we wanted to really suggest 2 pipelines for people to go down. If you feel like you're a beginner in 3D modeling, we want you to try and think about all this and focus on Tinkercad, and we're going to talk about that first so you can see it. And then if you already have some experience, we'd like to invite you to try Fusion 360. We like this pairing because they're both Autodesk products, not that we love Autodesk more than anybody else. We're sort of ambivalent to the company. But all of the buttons sort of look similar, right? It keeps a narrative as you go. They even have a pipeline in the Tinkercad tutorials, and there's a ton of them on like how to go from Tinkercad to Fusion, right? They're actively thinking about that as a company in up training people. Of course, you can choose any of the others. If you do FreeCAD, it's totally free and open source, and that's great. It's just its own wonky system. This particular pairing is nice because it starts you somewhere super easy, and it gives you a natural progression. And that's really it. It's not like in 5 years, we might have a different recommendation. What's up?
Does Tinkercad work on Mac?
It works on the browser, so it works everywhere.
Oh, okay.
Yeah, Windows, Mac, and Linux, no problem. Fusion 360 is also Mac compatible. And I would be shocked if they didn't have a secret Linux version. Yeah, because they're similar. But if you don't like either of those options, or you've already got one that you love, you should stick with the one that you love. If you want to upgrade and you're on a Chromebook, and I don't think anybody here is, maybe, then you'd go from Tinkercad to Onshape. And if you really want to go at it hard, as a MakeHaven member, you do get a SolidWorks subscription. So first up, Tinkercad. Here we go. We're going to talk about Autodesk Tinkercad. We're going to look at examples. We'll play around in it. But we've got a few videos that we queued up. Here's the whole interface. Right, this is it. it doesn't do any other things. Everything's on screen all the time, which is you'll see is not the case in Fusion 360. And it's really, really nice that this looks the same constantly. Here's different features of it denoted, like this is the name of your design. They're always auto-generated at the first thing, and so you get weird bodacious Wilhelmo. Your view cube is here. You can click on that and rotate. There's a home view button if you ever get lost, and that will definitely happen your first couple of times. There's a few context tools, but they stay on screen and grayed out. One of the ways you know this is targeted for kids, this is standard view, this is Minecraft view, and this is Lego view. So you can see your designs in those three different.
Orthographic.
No, there's a different button for that. So this is, we'll look at it in a second. But it's a lot of fun. And then here, this is your sidebar where you just drag shapes onto the table. And that's it. There's no like trick or complexity or any of that to get started. It's really, really nice. And so it's a lot of fun. So what does it look like to drag things on? You just literally click on them and then drag them over. And that's it. That's the whole show. They start as 3D objects there on the sidebar and you drag them into place and they're 3D objects the whole time. So it's like playing with building blocks is what the engineers who designed the software wanted it to be like, and it's totally what it is. So you grab in your toy bin of the different blocks and you pull them onto the table and you can build whatever you want with them. So that's the core concept of this. Any other ways to spin this? What does this make you think about? It is. Yeah, it's great. You can see little like menus pop up that are there and helpful if you want to nudge things one direction or the other. So as you're interacting with a shape, as it's highlighted with a blue border, you can see there's different options here that you can play with. And it's a little different for each one. So there's some of that, but these are all the basic shapes that you can play with. The next thing that you can do is you can transform your shapes. So those little dots and markers and things around the edges, they all have a job. And you get dimensions and rotations and scaling. And it's pretty nice and easy. If you're into the idea of stretching and squishing this block or moving it around, it works really smoothly. There's not any trickery to it. You can raise and lower the things as well. And you can see there's little dimensions popping up. If you wanted to, you can type numbers into there and get pretty precise with this. I think that all of them on there are in millimeters. In this demo, you can switch it to inches. It's not a problem. And it's easy to drag things around and move. This, for all the simplicity that's here, the fact that you have this much control over how you move it really does enable you to make good engineering solutions with Tinkercad. So it looks as easy as playing with blocks in a play bin, but it is, and it works well at doing what it needs to. So it's a really nice thing. But let's say you want more than the basic shapes. You can add complexity by doing combinations. So here's a cube and a cylinder. And with this combine tool in the top, this one up here, they weld them together. And so you can get complicated shapes. And then these ones that are grayed out, those are holes. And if you combine a hole, it's a cut instead of an addition. So you can make cuts away into the shapes. If you want more complicated things, you can make additions into the shapes. And that's how you can really start to build complexity within the volumes that you're working on. Another thing about welding is you can see the color shift. They become one singular object. And so if you were starting to wrap your head around objects in Inkscape, this is sort of the same deal, keeping track of what your objects are, but maybe easier because they're like three-dimensional objects in a sense. This combining and honestly, this combine tool that's up here that my GIF mouse keeps going past, that is my favorite tool across all the design softwares. I like to think about shapes in combinations and subtractions, and doing that is really, really helpful to start to think about how am I going to get these shapes to interact with each other. But I also really like Boolean math. Maybe that's a weird personal note, but just thinking about adding and subtracting shapes makes sense to me, like, because I've thought about these volumetric things for so long.
I really wish that feature was on the professional engineering software like Fusion, and like it's not that easy.
It is, and I'll show you where.
Oh,
it's hidden. It's not simple to find.
huh.
It's usually not visible at the top of the menu, but I put it at the top of mine.
Why wouldn't it?
I don't know at all. Okay, we're gonna go right now. Here's Fusion 360. There's that logo, and I put it at the top. It's in the modify menu, but it usually shows up down here and it isn't in Fusion. You can change your interface.
Oh, does
But-
Onshape have that?
Yes, but it's clunkier. It's not as smooth. But that is if I look for that tool, like as I'm starting a new software. Okay. And there's more than just these basic shapes. If you click, you can go find Elvis, which is a lot of fun. These are like designs that other people have made that the Tinkercad team put into place. You can totally just click through there. You can grab mountains, you can get houses, you can get whatever you want and just drag it into your scene. This is where I've seen, I co-taught a college class with somebody who taught third grade, and he had his third graders make animal enclosures to explore like what's the environment a lion wants to live in, which is pretty cute. And they'd like drag in trees and put little streams through their scene, and they were just pulling in these like slightly more complicated shapes. My high schoolers will still put like googly eyes on their 3D designs. It's pretty fun. I mean, it makes sense.
Yeah, why wouldn't you?
They sure do. There's other features. There's like other more complicated ones, like the text tool is really great in Tinkercad. You just write your text and that's it. You can choose a font. You can do the text. All of your stretch and squish rules still apply. So if you wanted to 3D print something with a little text on it, which is often very, very helpful, you can do that. You could even do this, and like if you want to make a soup here, I got it pulled up. Let's just get out of here. Escape. Let's say I'm going to open Tinkercad. Let's say you really want to make a cool nameplate for Ashley's desk. Oh God. Live demos are the worst. If we do this, here's that. Now we're going to type into this thing. Nope. I need to stop deleting it. Ashley. There we go.
Yep, that works.
Okay, all right, we did it. And then I'll take this thing, put it in here, and we can just sort of scale like that, and then put it down here, and boom, now you've got a nameplate. Those are two shapes. This one, let's change it to a different color so you can see like they're two separate things. But if we grab them both and then do combine, now it takes it a second because it needs to process. But then there you go. Now it's a singular object, and you can 3D print that and put it on a table, on a desk, wherever. And it works great. So
Side note, I put the link to the instruction to download SolidWorks through the MakeHaven sponsored in the Slack channel.
oh, that's great. Cool. Thank you very much, Ruby. It takes a second to load all these GIFs. There's another tool in here that's worth mentioning just because it's fun to see, and it's a little bit of a mind warp the first time you do it. The scribble tool, you drag it onto the work plane, and then it pops to a whole different view where it's like in Microsoft Paint, you just draw the shape you want, and then it pops it into 3D. So it's going to reset the GIF in a second. GIF, I don't actually know, but GIF. You drag it in, and now it's popped into like a Microsoft Paint view for the GIF for this thing. And you can see it's trying to generate it from what you've drawn up there in the top corner. And then it makes that a 3D shape. The scribble tool is a little weird to get started, but that is how it works. You can also, there's import. If you want to get even more advanced, you can import SVGs in, and then it turns them into 3D shapes right away. There's a lot of different, so you can go Inkscape to Tinkercad if you really want to. There's a lot of cool options that are available, but the scribble tool is a fun one because it really immediately adds full customizability to what you're designing. So that is Tinkercad. Anybody have other fun experiences with Tinkercad that you want to talk about, look at, see?
So there's actually, so let's say if you're like 3D printing or like using any other machine.
Sure,
How
yeah.
would you turn that 3D into like a 2D plane where everything's like separate so you can cut it?
Oh, good call. That's a good question. Let me do the fast version to show you. Yeah, so let me repeat the question. How do you take a 3D thing like this, Ashley, and turn it into something that's 2D? Well, you can take this, and there's an export SVG, and it basically slices off whatever you got right at the work plane. So if you do that, now it's going to download an SVG, and if I open this, will it open the right way? Maybe. It's trying to open. Opening. I think I would need to open it in Inkscape, maybe, or maybe it's down. I don't know. It's somewhere in here. It should work, but it exports whatever slices the work plane. I promise. I can open an Inkscape, but that's side quest.
So what you did was you dropped
Yeah,
it down so that the plate was below.
right. Because if I left it there, it should just give me a straight rectangle.
Okay.
Because, which is like, fine, you know, it's a reasonable thing if you wanted a rectangle, like a very dimensional rectangle. But dropping it through should give me the text of your name. If I go to Inkscape and open that up, which may take a second on the computer that has a few 3D design softwares open, but it ought to have downloaded like the sliced off right at the work plane. Sometimes it's easier to think about if you rotate around your design. And so this is something where you can often make more sense of it by looking at it from different perspectives. It can be really helpful. You can also get really lost if you just go, woo, which is fun to do for a minute. But then you hit the home key and it takes you right back to the basic view. So that's a good strategy to learn. The home button is really helpful.
What's a good online vector graphic program that could produce SVGs that students design and then import into 3D software?
No, that's a good question. And I was just trying to have this discussion with somebody downstairs. And I think Corel just bought Gravit, and and this is probably worth us looking at for school, but there's a browser-based vector design software. There's a handful, like Vector without an E at the end. And then their Corel vectors used to be Gravit is another one that might work. There's a few where like in the browser, you could handle all of this and take the vectors and do stuff with them. There's a bunch of options. Okay, we're going to try this live demo of a thing that I should have tested before we got here. But if I go to File, Open, and then grab the one from my sizzling dupe, they make up weird names. And if I grab the design, here it is. Maybe it's just white, but it looks like it's got a thing. And let's make it fill. Yeah, they totally did. So it imported it as white text, and that's exactly the font that it was. So it slices it at the work plane, and you can pull whatever you want. That's actually in 2 weeks. That's what we're going to talk about. But Fusion 360, if Tinkercad is if you feel like Tinkercad is something you did a long time ago, or what you're going to show your niece when you see her, and you want to do something a little more aggressive, Fusion 360 could be the way that you go. It means it's more complicated, not necessarily better for the job, right? Choosing the right tool for the job is an important part of what's going on. And if you want to make something super fast and you're not already good at Fusion 360, it will not be super fast. So choose the right job for what you want to do. But we're going to go over some of the basics with Fusion 360. This is its interface. Look at that. It's a lot more, right? So it's definitely more complicated. Over here, and this is even out of date already. This over here is sort of where all your files are saved, and they're all cloud saved, so that's great. There's this bar across the top where if you have multiple things open, you can see them all. Here's where all the tools are for a given window. This is all the stuff that's in your model, and in this little thing, that's a lot. Here's your actual like design. Number 6, there's your view cube. 7, if you right click, you get this crazy menu on the right click. Here's like your view controls, and here's your history and timeline across the bottom. It's a lot to look at, and it all changes as you work through different things. Like here's 4 different sets of menus and this is 4 different sets of controls all inside of the same design for Fusion 360. This is all just about, I just like loaded the model that I have up right now in Fusion 360 for the Wacom table downstairs and just clicked design, sketch, render, manufacture. They look this different when you're doing different things. And that is honestly, it's great when you know what the context of the menu is supposed to be. There's never too many buttons on screen at once. But it also means that buttons that you want to click it has disappeared and you're unsure why. So as a beginner, it's really frustrating. Once you're like already good at it, which is now we're talking about a Skull Island situation. You only know where it is if you already know where it is. For those people, it can be great. For beginners, it's not an approachable menu set. But I would say it's worth learning if you wanted to do it. So keeping in mind that you have a contextual menu is important. We're going to focus on sort of the big ideas. There's a few things you should know about Fusion 360. It's moody. It has opinions. Like here's a circle with a line drawn next to it. As a way to make it easier for somebody to draw things, there's often constraints already put in to the drawing when you draw it. So if I pop over to Fusion 360, here's that model. Let's make a fresh one. And I'm going to start to make a sketch. Watch how quickly my interface changes as I jump into a sketch. It just shifts around. I have to choose where I'm going to draw. Now my menu has shifted. I want to make a circle. So I can click a hotkey that's in my head. And then here's a circle. I can set its dimension if I wanted to. All of this can be really helpful. Maybe I want it to be exactly 120 millimeters. And then I want to set some lines. So I'll do L, and I can do a line that's just off like that. Maybe another one, and then one like this. Maybe I want this line to be always tangent to the circle, so it jumps it to the bottom. Maybe this one too. But I really want to have a defined. You can go really specific and really crazy all at once. Maybe these have to be 2 degrees apart from each other. All of this can be stuff that you set, right? As you start to spin up all of these controls, these are controls that don't really exist in Tinkercad that are very, very helpful. Like even just saying, I need this part to always be, this line to always be tangent to that circle is a really complex statement to be able to make. It's got a lot of power and a lot of really cool things to do. Like if and this is another live demo, things could go sideways. So bear with me on that. Here's the menu for the table. I had to design this not knowing exactly how thick the plywood would be. So I did it all parametrically, and this is something that you really realistically can't do in Tinkercad at all. But up is going to pop this menu. And right now, the thickness of the material is 0.7 inches because it turned out to be that was the thickness. But if I did 1/2 inch plywood, I can click this and then apply, and then my computer gets very angry at me. But it's recalculating the thickness of all of these pieces of wood. So watch like the thickness of this base or the thickness of the top. And as it finishes the calculations in the bottom right, it'll pop into space here a whole different set for the sizes of the wood. So that is something that's really powerful. It's also really, really advanced. You do not get there in your first months of 3D design, but it's really, really helpful. So that when I walk up to the machine and I actually measure the piece of wood, I can just type in the number for how thick it is, and it just does it. And you can see there's a whole bunch of things. Like I have the base width, the depth, the mouse pad size, the caster height. How much tolerance do I want to have? As you get better and better and more advanced, you can really start to specify interesting and valuable pieces of your design in useful ways. Onshape has the ability to do this, which is a browser-based thing that a kid can do on a Chromebook, and that's incredible. The mechanism they use to do it is very different.
When you say parametrically, does that mean that you fit parameters?
Yeah.
And it works around those?
Yeah, when I define, so then let's get into the weeds. When I decide I want it to make a shape, like we're going to talk about extrusions, we're going to do things. But you extrude. And so you take your 2D shape and you pull it into space. For the thickness of all those pieces of wood, I extruded them and I defined them based on that number that had a name. The name was mat for material.
So it's going to be 4 feet tall no matter what.
Yeah.
And then, right, okay.
And then if I change the number, it might be 3 feet tall.
Right.
Right. So all those things I can adjust with the numbers in the menu. And then when I said, I want you to be a piece of wood that's 3/4 of an inch thick, instead of typing 3/4, I would just type in the variable name, mat. And I could change the number associated with the variable. But it's interesting and complicated, and you don't get there quickly. But it's super powerful. Okay, back to this. There's a lot of things that are hidden away that are really helpful, but they also come with a learning curve. Like these little shapes that seem meaningless at the start, they're all telling you about constraints in the design. These are tangent, this is a midpoint triangle, this is perpendicular, and it takes a lot of time to learn what those all mean. They're all up here in the constraints menu, but it's slow going. Another thing, this is one of the big differences between Fusion 360 and SolidWorks. SolidWorks handles individual parts, and then you have another file that brings them into assemblies. You've had to deal with that stress? Yeah, a little
I,
bit.
like, looked at it and tried it, but not really like deep dive, but yes, that's.
And I find the way that SolidWorks does it with that, I think I see why they did it that way in the past, but I think it's conceptually harder to approach.
I agree.
Yeah, Fusion 360, everything starts with, you can have as many parts in it as you want. It doesn't matter. Everything is an assembly by default. And so you don't have to like design the separate parts and then bring them together. They're just already assuming you're going to have a bunch of parts, and you don't have to think about it as a last step. It's right there at the beginning. That doesn't mean a whole lot for an early designer. Like you're many steps away if you've never done this stuff before, but Fusion 360 is assemblies first, and SolidWorks is like assemblies last, where it's the last detail of how do you coordinate the things, which is probably not
That's
fair.
because they're designing from the 2D.
Yeah. Yep, because they started designing from 2D. Okay, so what does this drawing in 3D even mean? First off, you cannot learn it all at once. It's impossible. It's going to take a long time. It's very slow. Here's sort of the loose path that a fever dream came up with. I know it's too much. You start off with sketching and then extruding and then other stuff. And then like components and bodies becomes a question. Then you start paying more attention to details, and constraints and parameters show up sort of in this intermediate land. You start off with, these are all the basics. Then you get to the more intermediate stuff. And then like the advanced is like joints or sheet metal. Fusion 360 can handle sheet metal bending and like sheet metal planning, which is really wild. And I've actually used it before to make the acrylic dust shoe for the Gerber. I designed that thing, and even though it's acrylic, I just lied to Fusion and told it was a piece of sheet metal, and it worked. I could make bending forms and plans for acrylic, and we just bent the acrylic on a hot bender, and it works great.
I would also say just, give yourself some grace as you're trying to learn these softwares, because it's not always super intuitive when you're getting really into it.
Oh yeah, it's really hard. Yeah. So let's start at the beginning, right? Instead of talking about the big picture and all the advanced stuff, let's begin where we should begin. You draw sketches, right? This is back to the old engineering style. You start off with a sketch. Here's a sketch of a doghouse. You're just thinking about the 2D surface, sort of a two-dimensional representation of what's going on. And this is relatively nice, right? It's a rectangle. You put a triangle on top. Here's another one for like the opening, and then you half circle on top of that. Easy peasy. You're just drawing what a doghouse looks like. On here, there's a bunch of other lines. Like these ones are dimension lines. If it's got an FX, it's probably a parameter instead of a typed number. Like these are parametric. This example is parametrically designed. And then these lines here that are X's, they may not seem like much because I drew it as a certain type of rectangle when it came into existence, but it doesn't matter. Any way you draw the shapes, they're totally valid. One thing that is useful to know, though, is that a blue line in Fusion 360, it doesn't exactly know how it'll behave if you change sizes on it. It's not a locked line. If it turns to the color black, it means it knows where it belongs in the sketch. And that's a thing. If you want to think about constraints, that's something to think about. When you get started, doesn't matter. Black, blue line, whatever. Just draw the drawing and don't worry about it.
So black is locked. in
What's it
place.
called?
Yes.
When it's blue, it's an unconstrained line. Yeah, and when it's black, it's got a full enough set of constraints that it'll behave in a predictable manner. Like when you, like, for example, this dimension here, if I typed in 25, all of the lines would know exactly what to do because none of them are blue. If one of them was blue and I typed in 25, I have seen that angry blue line get like 48 feet long and like go at 15 degrees in a weird direction. Like if they're all black, then they know what they're doing. Oh yeah, Mike.
Oh, just that, if it's black, it's like locked in, or?
It has constraints fully defined. So like, which,
You can't move them around.
yeah. Let me show you. Let me actually show you what I mean instead of trying to hand wavy it. So here's, grab all this and delete it. So this blue line right here, I haven't given it like instructions on what to do yet. So let's say I change this 120 to 400. and everything changed, but that blue one didn't know what to do. So it just kind of stayed, assuming that I wanted it to do that. But if I tell it that I want it to be, if I want this line to be vertical, it'll stay vertical. But if I go back and change this back down to 200, that moves, but this still doesn't know like how far away it could be. The somewhat, and it's barely the constraint that this one's really waiting for. Where'd my cursor go? Oh boy. Doing this without a mouse. Alt tab over to here. My cursor is fully lost. Dun, 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 dun. Okay. The constraint that it really needs is to go from the blue line to set a dimension to that center point. So if I set like that needs to be 3 feet away, always forever, it'll turn black in that moment and it will behave accordingly. So it's just learning like what are the actual constraints that you need to use, what are the things that you want to have going on, and how do you make that happen? It takes a lot of practice to like get to a point where that all makes sense.
The constraint is a direction you give it. Other
Geometry.
geometry. Okay.
Yeah. So like the two tangent lines there, I've given those constraints that they have to be tangent to the circle and 2 degrees apart from each other. So that's enough constraint on that geometry that it knows how they should behave if I change things around them. And so that's what that means, but it's subtle and advanced, and don't think about it at the beginning. But a few of you are there, so we're having the talk. Extrusions. So you've got your sketch. We're going to stick to the doghouse because it's a simple example. Oh, there, my cursor is maybe there. Extrusions bring sketches into 3D. So extrusions take those 2-dimensional drawings and they pull them into 3-dimensional shapes. They can be positive or negative. The way that Fusion 360 shows it, a solid one pulls in with the material that you're extruding. And so it's by default steel. So it's by default gray. Although it could be whatever, if you're making it out of wood or plastic or whatever, it can be that color too. But typically it's gray. So you drag it into existence and it turns into the material. Or if you're trying to do a cut like the one on the right, it turns it into the red, like clear, to show it's cutting away at something. So there, in that case, it's cutting away at the door of the doghouse. So extrusions just pull 2D shapes into 3D. Another fun way to make geometry is you can do a revolve. So if you have some sort of a sketch, like the slice of a donut, perhaps, and then you take that donut and you revolve it around an axis, a 3-dimensional axis, you can make a donut revolve in the way that it's showing up there. This is another fun way to describe geometry that without this tool is kind of hard to make a circular thing. It's possible, but not as easy. Here's the combine tool inside of Fusion 360. If you start off with the red thing up in the top, if you've got this like red object happening with the teeth in it, and then a blue one that you'd like to have mate with it perfectly, you could go to the trouble of designing in the opposing teeth, and that is totally fine and a workable solution. But it's way easier to just have the 2 sort of overlap in space, and then use the combine tool to have the red teeth cut into the blue thing to make the matching blue teeth, which is what that GIF is sort of slowly stepping through up at the top. There's the red teeth. Here's the blue teeth that came out of the process. So there, what?
It's a fun beginner project.
It is a good beginner project. And like, if you wanted to build your own maker case thing, this is really helpful. I've designed them both to mate before, and that's gross. You don't want to do that. Use the combine tool so you don't have to draw both sides of every one of those like zipper edges. Yeah, that's a lot. So this is still with Fusion 360, like just to see the crazy complexity that happens, this is still not we're entering the advanced ideas. So this is where
I have a quick question.
Yeah, what's up, Ibrahim?
So do you know if you can do the same thing in other CAD software, the combine tool?
Yeah, the combine tool exists in Onshape for sure. I'm almost certain it's there in SolidWorks, but it's been years since I've looked at it. And okay. I don't know in Creo because I haven't played with it really.
What about Autodesk?
Autodesk, the software, we probably need to get into what version of Autodesk you're talking about.
Okay.
Yeah, to answer that question.
Sounds good. Thank you.
Yeah, no problem. Here are the more advanced ideas. We did jump into some of them early, like components and bodies. Oh, it's trying to have a mouse. Oh, I think it's freaking out that it's also touchscreen up there. That's what that is.
Oh,
Yeah, isn't that fun? Look at it. It's freaking out on the touchscreen.
yes.
Oh, now it's at the top. Components and bodies. So that, wow,
Oh, it's having a hard time.
it is having a hard time. It's fine. So in Fusion 360, when you're doing things, you want to start with a new component. Components are just objects. Remember how we said they're assemblies first? The components are the objects in those assemblies. So if you want to make a new thing, you make a component and then you do all your design work from there. It's not something I paid attention to. I'm going to go with for 4 years of using Fusion 360. This is not an immediate problem. However, if you want to get better faster, doing this is really helpful because it will separate out the history of each component differently. So if you wanted to look at the history of the top of your Wacom stand versus the sidewalls, you can track each one of those without conflicting each other. So it's really, really helpful. But it's also strange. The bodies are the physical objects, and a component may have one or more bodies in it. But that is a more advanced idea to think about. Sketch constraints. If there's one advanced idea I would recommend you try earlier than you think you're ready for it, it's sketch constraints. And honestly, at this point in life, I am really sad when I have to use design software that doesn't have constraints in it anymore. Like I just started to think about like, I want this line tangent to that one. I want this line to be in the same plane as that. I want these to be parallel. Like being able to make those sorts of decisions and impose them on your designs gets to be very valuable very, very quickly. And so thinking about your constraints early on is important. And this is rule number 3. Rule number 1 is always start with a new component. I don't know where rule number 2 went. It's gone. Oh, yeah. Always rename them. Yeah, renaming them is really helpful. Otherwise, they'll be component 1, component 2, component 3. And that is not helpful at all. Yeah, so renaming them, you just right click on the thing and you can rename them. Although I can't because my cursor is held hostage by a ghost. So parameters are really helpful for this. This is the doghouse that we've got a video that we've got linked for you to check out if you want. It's about a half an hour long, I think. It goes through how you'd use parameters, but it's a fun reason to make a doghouse because dogs come in all shapes and sizes. So if you have a parameterized doghouse, you can it's kind of fun, right? Well, yeah. And those are like dimensions that are set up that might be dog width times 3. Like you want the dog, whatever the dog's width is, you want the dog house to be 3 times as wide. So it can like turn around inside. But you can change if it's a very different size doghouse, if you have a Great Dane or a Chihuahua. So making it parametric means that you can take the same design and just type in a few numbers. And now you have different size doghouses for different size dogs. So it's a pretty it's kind of a reasonable starter application if you wanted to learn this, where it's a relatively simple shape and it gives you a good reason to come up with parameters and try them out. So it's a good starter activity, and there's a video that will totally walk you through, even if it's kind of long and a little hard to.
It's great. What do you mean? 30 minutes? It's okay.
Yeah. I think for this one, I even found a way to put all my keystrokes on screen. Just like you can watch the mouse clicks and buttons I'm pressing on the keyboard while you're doing it, which is really, really helpful, actually. Yeah. Oh, yeah. Thanks. It took a lot of effort to figure it out. I get why they don't. Here's another even more advanced thing. Once you have a whole bunch of shapes and bodies and components, you can start to describe joints. So like on this Autodesk example box cutter, they described the connection between that slider piece and the body of the knife. So in the design software, you can check. If you're an automaker, you definitely want to use this to make sure that when someone opens the door, it doesn't crumple the door, right? So learning how to do this is certainly a skill you'd want if you're going to be designing helicopters for Sikorsky, but it's probably not the first thing you'd want to learn when you're doing your maker stuff. But it is really, really neat. So, and then I think this is our last advanced thing. You can also do patterns, which is really cool. So if you were trying to make something like this, I don't know, maybe candle base or a pipe with more other pipes coming off. Sprinkler? Yeah, that looks like a sprinkler. You can define your geometry in lots of interesting ways and then like do patterns and things along that shape. So this is another really complicated, like high level piece, but you can define like one sprinkler head and then copy it along the sort of serpentine geometry of that if you've defined it all the right way. So there's some really cool things that are possible. And it will take practice to get there. But then once you get there, these are really neat tricks that can be very, very convenient because drawing this in manually would take so long and be so painful. So having these tools accessible is really useful. Things like these ones here, joints and parameters and these like patterns along a path. Though to me, those are the signs of a fully mature 3D design software that's intended for an advanced high-level user. It's not what you should go after if you were thinking Tinkercad looked real fun and like you'd never done it before. But these are great when you get there. So let's say 3D design altogether, you want to try different other stuff. There's alternative ways that people nowadays are designing things. So generative design is a really, really cool one. These are like how space age things are being designed now. The thing on the left up in that picture is sort of a mounting bracket, right? Where you might have a few things bolt together and you need to have those holes in just the right spot. And it needs to be a cylinder and it's welded together. Sort of relatively easy to cut, easy to make, simple to wrap your head around. We've now got this is a feature of Fusion 360 that you can actively use and that goes on sale regularly as free. Like it's a paid service of the software, but they'll like every 6 months it goes on for free use, which is really cool. You can design exactly your mounting brackets that you want and then have the software design what's the least material I can use to make the bracket you're asking for. And so it will come up with designs and say, here's 15 options. Which one do you like the best? And then it will spin that out further and try and do more things. It's how you get these crazy like space age, artsy sci-fi looking things that would still be a perfectly good mounting bracket. And the software is going through the trouble of like trying to figure out where does it really need reinforcement versus where is it just sort of like there because it was easy to cut a pipe. And so that's a really cool thing. There's other ways that you can do it, but there's like articles and articles and articles on this exact thing. This is how you take like airplanes and fighter jets that we know how to build really well, and you make them even more optimized by finding the most balanced and most optimized configurations. And it's a part of Fusion 360. Here's some more nervous system labs, which we did talk about. Down in the bottom, that's probably grasshopper design, where you have sort of flow charts of things come together. And the Metropole Parasol in Seville is a good example of how you can have all these parameters come together and help you design things in interesting parametric ways. So Fusion 360 calls parameters like the variables for numbers. Parametric design as a category is sort of a poorly named, because it's the same name again, system where you use just constraints to describe how you want it to be built. So like in the case of that parasol thing, the Metropole Parasol, I'm sure that somebody went in and said, we want to have wood slats that overlap and interlock to each other with some bolts, but really just sort of fit together. And then they designed like, here's the 4 places where we want it to touch the ground, 4 or 5 places. And we kind of want this weird organic shape between them, design. And then the software designs it for you and you export all the manufacturing files and then you just build what the machine has told you to build. It's really, really cool. Yep. Oh boy, my cursor's going even more nuts. And oh man, we're going to start unplugging USBs. Start ditching stuff.
Nope.
Still going.
Not that.
Nope.
So,
Wait,
okay.
yeah.
All right.
We'll see what happens.
Yeah. Maybe we got rid of the ghost. I don't know if we have sound.
No.
No,
But-
they don't have power downstairs anymore.
Oh, yeah. Oh, my cursor's fully back. Look at that. We got it. All right. So another thing that you can do is CAD simulations. This is available in Fusion 360 and SolidWorks, and it's really, really helpful if you're doing that high level stuff. We will not use it as makers. Sorry. I mean, maybe you will, but probably don't. It's cool. It's fun to watch a video of someone do this. Don't try and figure it out. I'm not. I have turned it on and then promptly turned it off. I feel the way about this, like some people do when they open Excel on accident. They just make it go away. So that is the quick overview of all of these. We've got lots of different things to look at. Oh, I'm going to make this constraint just compulsively. So it's not constrained in this direction. If I do D, I can set it to be defined away from here. And if it's that, and we make it 300, now it knows exactly where it belongs. So it turned black. Sort of closing that narrative loop. It is. Yeah, it was bothering you. I know. But that's the name of the game. And if I change one of these, like if this goes up to 300 as well, then it knows what to do with that. It should always stay exactly 300 away. So that's what this is all about. Learning those constraints is important if you wanted to do that. But if that feels painful, the good thing is you can just pop over to Tinkercad and like keep on making fun signs, or go into the basic shapes and like get an adorable chicken foot ice cream. You can just make ice cream added to your thing. More shapes over here. Oh man, I want this lucky cat. So don't I really love Tinkercad also. It's really it's great. You should play in Tinkercad first. Spend a minimum a half an hour doing that because it's just fun. No matter how good you are at 3D modeling, it's just fun. And if you want to just stay in this space for forever, there is no hard feelings. No one's going to judge you at all for it. It is very useful for many, many years. There's still moments where I'll pop into here because it's just fast. There's no like reason to think, oh, I should go to the most hard, difficult thing in the world and make it that because it's most advanced. Just do what works. And I'm sure as a bunch of adults, my high schoolers will get caught up on, I need to achieve in order to be successful. And that's great. And I love them for it. And it's the right thing for a teenager. But at some point, hopefully you've wandered down the journey of like, I just need the tool that works. And that's a lot of the time that's Tinkercad and it's perfectly great. I mean, look at this. In 2 seconds, we get a cat with glasses. I'm in. That's 100%. So circling back, we talked about all these things. What should you try and do with 3D modeling and maybe 3D printing? So the big thing to suggest is try one of these softwares. This is the assignment for the week. And in a Maker Center world where most of the stuff that we do is stuff with your hands, this is really sort of a software week. So grab yourself a computer, maybe a cup of coffee, and just go to town. Tinkercad is great. Fusion 360 if you want to. I'm more than happy to sit down with all of you and work on these things. There are official Tinkercad tutorials. There's official Fusion 360 tutorials. If you want to watch specifically about the interface and components, that's probably a good place to get started for Fusion 360. You can make a desk organizer. I think these are links to actual like videos. Yeah, these are videos that I've found or made. This one I didn't make. Teacher desk nameplate. I think I did make this one. Yeah, it's my name on the thing. And you can watch these if you want. And then the Fusion 360 desk nameplate. There's a bunch of options. But I think it would be fun if by the end of the week you got to 3D print something that you had designed. It's sort of a fun achievement unlocked at the end of the week if that's your jam. Also, no pressure, just playing around in the software can be great.
It's using the browser based, or do you have to download it like Inkscape?
That's a great question. It is a download like Inkscape. And let me say this clearly and resoundingly. The Fusion 360 is free for educators. Education. There is a personal use. So if you have a student email, or if you are a teacher and there's a few of us that's relevant for, you should absolutely 100% sign up with this because it's full unrestricted Fusion 360.
Yeah.
The Fusion 360 hobbyist is also free and it's great. And you'll probably never run into the barriers until you're designing CNC work out of Fusion 360. Because what they tried to do is they ran into a problem early. They had a really generous like hobbyist tier. If you made under I think the number was $100,000 a year with the software, it was free, which is great. And most people don't run into that barrier. But what they found is there were some small businesses that just weren't paying, and they were definitely like breaking the rules. So the knob they turned is cool. You can use our software for everything, but if you're going to do CNC designs, which is like really what a business would do with it, they said, great. You just can't run any rapids with our design. We're going to let your machines will run. They'll just run really slowly and pay us if you want to get full access. Which is totally reasonable, actually. And for a maker here, that means that your project on the CNC goes from an hour to an hour and a half. That's not a big deal. If you're a business, that's a big deal, right? So that's the knob they're turning. But the hobbyist tier, let's see, Fusion 360. So they do kind of hide it. So search Fusion 360 education or hobbyist, if I spell that right, hobbyist limitations for personal use. For most people, this is going to be what you do. And you can see they limit some of the things. Generative design, you don't get. An Eagle Premium, you don't get, but it's free and you get started and it's fine. If you want to pay, it's $550 a year. I would solidly recommend free over $550 just because it's the only reasonable choice.
What is that half circles?
That like you can't import or export everything. So there's a limit on how much. Yeah, I know. It's a little funny, but it's what they did. Sorry, Ruby, what was up?
I'm just dropping it in Slack.
Oh. Thank you. Yeah, so like a lot of this is that they have a limited subset. It's like the preview of what you could do if you paid for it. And it's ultimately because they want to make sure that the businesses that are using it for business purposes pay for a business license. And so usually it's that you can use it, but like there's a limit, like the no, it's oh no.
Did you buy it at the Maker's Business Facilitator with Educator?
No, they probably won't. It's a bummer. But if you're a high school teacher, or if you are,
You have
or if you're
2 months left on your.
if you have 2 months left on your
bachelor's.
college bachelor's, you can totally do that. That all totally works. And so those are great licenses to get. If you're tied to if you have any sort of a college email at all, I would give it a shot. Because that's what it's intended for. And you may as well claim it. But it still totally works. Oh boy, no, they're really serving ads. But it's great. It's worth trying. And the hobbyist tier, you'll have a lot of fun with. And you probably won't even notice that it's a difference for a long, long time. So that's the summary of 3D design and Tinkercad and Fusion 360. Tinkercad is great because it's just like I'm in a browser. It doesn't matter. The computer doesn't matter. Windows, Linux, Mac, it's all fine. In here, if you wanted a 3D print, like let's say I want to 3D print this adorable cat friend, I've got this all selected. It's a solid rainbow, which is lovely. If I want to 3D print that cat, I'm gonna select only the selected 2 shapes. I want to download it as an OBJ, STL, or whatever the heck that is. And I'm just going to download the STL. And it can go straight into Prusa Slicer. So I'm opening Prusa Slicer on the other window of the computer, but it should just pop right in. So here's the sizzling dup. That's the name of it. I do love the crazy design names in Tinkercad. And it's honestly very helpful because you never forget them. Another thing, just as a general point of benefit as a teacher, Tinkercad also has fantastic classroom management aspects to their software. So if you happen to be a teacher watching this, there's some really cool things that you can do in terms of managing kids' designs and all of that. But let's add sizzling dupe right here. Yeah,
Let's just take a sizzling tube right on.
that's a lovely sizzling dupe.
The names are pretty good. I'd love to know the algorithm.
I really want to know. But that's it. I mean, this wouldn't be a great one to print without supports, but you throw some support if you're really committed. You throw supports everywhere, or on enforcers. You throw them everywhere and you slice it, and boom. Now you've got a thing that you had 3D designed in just a couple of seconds. You pull it into Prusa Slicer, and now we're 3D printing what you had made. All those supports are really excessive. That would not look great, but it's there and it's fun. So, and 4 hours later, you have a lucky cat with glasses on. That seems delightful.
And you're gonna take a sizzling tube. You want some support?
Yeah, the sizzling dupe does need support, but
Sorry.
No.
child.
It's pretty funny. It's pretty good.